So, first things first, what exactly is data engineering? Often folks introduce it by showing things like Apache Airflow, Luigi, Cassandra, Hadoop, Spark, and they say data engineering is what you use these technologies to do. And if you don't already know what you do with these technologies or how to use them, it's kind of this circular definition. So in this video, I want to get at the concepts irrespective of the frameworks or technologies that you can use to implement these concepts, and kind of give an overview with links to resources in the description if you want to learn more of what data engineering is and entails and how you can kind of break into it and start teaching yourself. But just like data science, data engineering is pretty interdisciplinary and kind of hard to pin down exactly because everyone has a different idea of what it is to them, what it is to their company. But generally, I like to think of it at the intersection of these three domains. And because people seem to love Venn diagrams for these things, I would describe data engineering at the intersection of DevOps or infrastructure, typically things that maybe a system administrator might handle, provisioning hardware and servers, and basically just running infrastructure in the cloud, intersected with traditional software engineering. And in this case, there is a little bit of an overlap. But for me, software engineering is really the abstractions around building software. So just like a civil engineer has some set of practices to make sure that a bridge is stable and safe, a software engineer has their set of practices to make sure that software is robust and reliable and scalable. So the software component of data engineering typically involves things like designing an API interface, testing, building data models or schemas in a database. And the last bit, I would say, is a little bit of data science. Again, you could say that data engineering is a subset of data science, or data science is a subset of data engineering. Really, I kind of see them as siblings. So there's some things that you do only in data engineering. There's some things you do kind of only in the domain of data science. But there's this intersection of things that could fall either in data engineering or data science, really depending on where you're doing it, what the rest of the team looks like, and who's responsible for each of these things. And the canonical example that I like to give for what data engineering is the extract, transform, and load pipeline. So this is kind of a long-running example that we'll keep coming back to in this video and in future videos, is how do we design and architect a data pipeline essentially to read in data from some data source, whether that's the internet or some web scraping crawler or just a database for a web application. How do we transform that data into kind of a canonical representation that is really suited to analysis? So the transform and the load are really geared towards what do we have to do to our data to transform it from this kind of raw source into something that is more amenable to analysis, statistics, machine learning. And then the load aspect kind of goes hand in hand with, I would say, the previous transform aspect. And this typically involves storing that raw data in a form, in a well-defined schema, in something that's consistent, reliable, predictable for the analyst. So I think of the database schema almost as the API for the data scientist, if you will. So the data engineer's job is to prepare the schema and design of something like a database or where the data is being stored once it's cleaned up, so that the data scientists and the analysts all have a consistent interface to query the data, to run statistics and models on the data. So, second thing second, how do I get started with data engineering? What things should I learn? What resources are out there? So for each of these topics, concepts, in this video, I'll provide the overview, almost a curriculum, if you will. And these are the things I'll be covering in my videos. But if you want to see what each of these is about or what it entails before I make a video about it, I'll link to my favorite, best freely available resources to learn these things. If you have a favorite resource, course, tutorial, video that I don't mention in this, and you think it will be helpful to other people learning data engineering, feel free to post in the comment, and I'll put it in the long-running list of resources to learn this. So I've kind of categorized this into 5 units, if you will. The first of which is kind of data preparation and data management. This would, if we're thinking of the ETL pipeline, be the extract and first half of the transform phases. And this includes things like data cleaning, data integration, which is just a fancy way of saying combining different data sources. So this is similar to the idea of a join if you're coming from SQL. Let's say you have one data source that's something like articles from the New York Times, and you have another data source that maybe it's restaurants from Yelp, and you're trying to figure out how can I combine these articles with any of the restaurants they talk about or mention. That would be data integration, is figuring out how to join articles to the restaurants themselves. And kind of the last concept in this first unit is what's typically called data lineage or even data provenance. It's where does data come from? What does it describe? How is it structured? What are its data types? And then kind of coupled with that, I would say is schema evolution. So if you do have a data set, if you do have a data source that's well defined, is it always going to stay in the same structure? Are there going to be columns added, columns removed? And this is kind of the job of the data engineer, is to unify and kind of provide a seamless interface to some data source. For number 2, I would say this is kind of the canonical thing that people maybe think of when they think of data engineering, and this is high performance computing and parallel data processing. This is where frameworks like Hadoop and Spark fit in. And while this is important, I would say it maybe gets too much attention in the whole pipeline of things. People focus too much on this one section of, I have my data, I need to do some transformation at scale across terabytes or petabytes of data. How do I do that? And they spend all of their time on just this transform stage. And in this unit, I would say you have things like just parallel data processing architectures. So this is cluster computing frameworks, but also cluster orchestration. So you have some pool of resources in your cluster, you have some set of data, you have a bunch of maybe data scientists or data engineers who need to run some algorithms or do some transformations. How do you most efficiently utilize your cluster? And how do you do things like authored data workflows? So also in this, I would probably group somewhere in between data management and parallel data processing. I would put things like Apache Airflow, Luigi, and those sorts of scheduling frameworks. So they kind of straddle the first and the second unit here. The third unit is kind of its own self-contained subdomain. This is just databases and systems. So this is the very traditional computer science-y domain. This is where there's tons of researchers and years of research going into how do we build scalable systems and databases? How do we ensure consistency when we need it and we don't enforce it when we don't need it? And just with systems and databases themselves, again, this could be and is its own domain. So the data engineering intersection with these databases is kind of a smaller subset of just systems as a whole. And for data engineering, we're not necessarily going to concern ourselves with the software engineering of how do you actually build these databases, even though that's a part of it. But for the data engineer, it's more of how do we efficiently use these databases? How do we build an architecture or a structure that makes sense for our use case, so that the data scientist doesn't necessarily have to know about distributed systems and know about more low-level things that are kind of tangential to their analysis. So the fourth unit is similar to databases and systems, kind of its own computer science subdomain. This is typically algorithms or scalable algorithms and things that handle data in a streaming fashion or kind of make approximations. And again, this is its own field of computer science and theory of how do we make and design algorithms that are efficient and scalable, But in the data engineering kind of little slice of the pie, I would say this is a lot of how do we efficiently either query data or efficiently filter or sort. So on one side of it, you can do more scalable analysis, either by scaling your system, your hardware, your cluster, or by scaling your algorithm. So it's working smarter rather than working harder. And the fifth unit, I would say, that is kind of the hot thing right now with data science and data engineering. Sometimes people call it machine learning ops. This is how do we deploy machine learning? How do we monitor machine learning in production? How do we do things like active learning to label data? How do we do efficient parallel distributed hyperparameter searches? And I would say this fifth one is in the zeitgeist now, mainly just because all of these other 4 units have been a problem since the beginning of doing data analysis and have been studied a lot. Whereas a lot of the machine learning ops is really only coming to the forefront when companies are trying to deploy these algorithms that typically might have only been in a research setting. So if you're doing research on machine learning, you're not necessarily worried about what do I do when I need to scale this algorithm to millions of users. Those are tangential to the machine learning problem. And while there is a recent ML systems research push emerging, again, a lot of this really comes from these algorithms are good enough, we have enough data, and the systems are fast enough to process them that they're being deployed in real-world settings. And that kind of ends this video. Again, I'll put links to things that I found helpful when learning these. And if you do want to have some resources, if you do want to do some self-study, those are great places to go. And these videos are really kind of my take on my condensing and synthesizing of all these things to hopefully make it a little bit more palatable to someone coming from data science. So if you are a data scientist who needs to start dabbling in more data engineering, whether for fun or at your company, this is the video series for you. Or if you're a software engineer who wants to get more in the data side of things, you've done software engineering, you have a pretty good handle on programming, coding systems, and now you want to transition into data engineering, data-intensive systems, machine learning, and AI, this is also the series for you. So hopefully this video helps you kind of contextualize what data engineering is. If you have any specific questions on things I mentioned in this or need more resources to learn a specific framework or topic, feel free to just post in the comments. And if you have something that you've been trying to do, banging your head against the wall for a while now, and you want me to make a video about it sooner than later, also post that in the comments. So hopefully I'll see you around, and good luck in your learning journey.